Hi, my name is Marcy. I own Regal Tutors and I tutor calculus. So today I'm going to go over with you calculus discontinuity. So we'll talk about whether or not a function is continuous, and if it's not continuous, how to decide which type of discontinuity it has. If you get confused, you can always follow along at my webpage. It's regaltutors.com/calculus-discontinuity/. All right, let's get started. First, let's go over the types of discontinuity. Of course, there are some graphs with no discontinuity. That is when the function is continuous. In this case, all limits exist. So here is a picture of a continuous function. There's no discontinuity here. Next, we have removable discontinuity. The function is not continuous because there is a hole. In this case, all limits exist. So here is some removable discontinuity. So you can see the function goes along, but there's a hole. Next is non-removable discontinuity. The function is not continuous because there is a jump or there is an infinite portion which leads to an asymptote. So you can see there's two types of non-removable discontinuity. Here we have the jump, so it goes along and then it jumps to a different spot and then comes up. And then this one has an asymptote. You can see right here the red lines on the graph never cross this line where the asymptote is, and that is infinite discontinuity. If it is a jump discontinuity, then one-sided limits exist at the place of the jump. If it is infinite discontinuity, then no limits exist at the place of the asymptote. It's easy to tell the types of discontinuity when you're looking at the graph, but what if you're just given the function? There is a series of steps that you can take. First, step one, you need to decide if it is a step function. This is what a step function looks like. You can also tell if something's a step function because it'll have double brackets or single brackets around it. For example, the step function y equals x has the different breaks. So if yes, it is a step function, then it's discontinuous and it has jump or non-removable discontinuity. If the function is not a step function, then you need to go to step two. For step two, you need to decide, is it a fraction with a variable in the denominator? So yes, there is a variable in the denominator, there is likely discontinuity. For example, if you look right here, f of x equals 1 over x squared, you can see there is a variable or a letter in the denominator, right, the bottom part of the fraction. However, there are still more steps you need to take to find out if for sure it has a discontinuity feature in it. So let's go ahead and go to step 2a. Step 2a, can the denominator be factored? If the answer is no, the denominator cannot be factored, then the function has non-removable discontinuity because there is an asymptote when the denominator equals 0. So if you look at right here, this cannot be factored, it's just x. So when x is 0, there is an asymptote right here. This one with 2x minus 5 on the bottom, the denominator is still not factorable, and what you want to do to find where the asymptote is you want to set the denominator equal to 0, and then go ahead and solve for x, which in this case x is 5 halves. It is discontinuous at x equals 5 halves. And if you notice, 5 halves is 2.5, so you can see that there's an asymptote at 2.5. Now let's say the denominator is factorable, then that means you need to go to step 2b, which is factor both the denominator and the numerator. So here we have an equation, the bottom can be factored, so we'll go ahead and factor it out. And you can see that these ones right here in blue are the same on the top and the bottom. So step 2c says find the terms that can be crossed out because they are in the numerator and the denominator, right? So those would be the blue ones. Once you've found the cross out terms, set them equal to 0. The function is undefined at those points. Therefore, there are holes creating removable discontinuity at those points. A hole right here, that is when the blue numbers, the ones that we crossed out, that's when that equaled 0 at x equals 2. Now you need to go to step 2d. You need to find the terms that cannot be crossed out because these are only in the denominator, right? So that would be like these black terms, they cannot be crossed out. If there is a time when these terms equal 0, then there are asymptotes creating infinite or non-removable discontinuity. You can see right here there's an asymptote at x equals -5 because that is when this black number right here was equal to 0. Sometimes the term cannot be crossed out or never equals 0. This means that the function is continuous unless there was discontinuity because of other terms, right? Like from other steps. You can see in this example, x squared plus 4 can never equal 0, and therefore it does not have any discontinuity in it, so the function is continuous. Say that there is not a variable in the denominator. That means you need to proceed to step 3. Step 3 asks, is it a piecewise function? A piecewise function is when there is like two equations in one, and if that's the case, you're going to have to just go ahead and graph it. just quickly sketch a little graph on your paper. You can draw the lines and sketch it out, and then you'll be able to tell by looking at it. For piecewise function, you need to check if all of the pieces touch. So if yes, all of the pieces touch, like in this one right here, then that means that it's continuous. However, if there's a hole, that means removable discontinuity, and if there's a jump, that means non-removable discontinuity. If it's not a piecewise function, then you can proceed to step 4. Step 4 is deciding if it's a tan, cosecant, secant, or cotangent function. If yes, then the function has infinite or non-removable discontinuity. You can see right here, this is a cotangent function, and there are a ton of asymptotes, so therefore it has infinite non-removable discontinuity. And if the answer is no to all of these steps, then the function is continuous. That's it for calculus discontinuity. If you need more math help, I am available for private tutoring. If you live in the Los Angeles South Bay, I can do in person or virtual, and then of course I can do virtual if you live further away. To book a lesson with me and see my prices and availability, you simply go to my website, regaltutors.com, and I do all online booking, so that should be pretty simple. Also, make sure to like, follow, and subscribe for more math videos.